Good day and welcome back to another physics lesson with Mr. Simons. This lesson we're looking at atomic combinations and intermolecular forces, right? It's from November 2017, question 2. In these questions, normally we test Lewis structure, shape, if it's linear, trigonal, etc., polarity, polar, non-polar, electronegativity, what's a dative covalent bond, etc. But let's look at the question. So in November 2017, they say consider the following two reactions of methane gas, CH4. So in reaction 1, methane CH4 reacts with HCl, hydrochloric acid, to form CH3Cl plus hydrogen gas. In reaction 2, CH4 reacts with oxygen there to form carbon dioxide and water. Now, we can pause here and try to attempt to answer as many of the questions as possible, because after this I'll be explaining the solutions. Very important you get used to where we allocate marks, what we give marks for, etc. So number 1, can we define the term covalent bond? Draw Lewis structures for those two items. How many lone pair electrons are in the central atom of CO2 molecule? Identify one of the substances in reaction 2 that can form a dative covalent bond when reacting with acid. I write down the shape of a H2O molecule, shape of CO2 molecule, and then there, although the molecules of CH4 and CH3Cl have the same shape, CH4 is non-polar, while CH3Cl is polar. Give a reason for the difference in molecular polarity. Right, so definitions we consider to be foundation phase. So let's go look at the definition. So covalent bond is the sharing of electrons, very important. So although we want to write definitions in our own words, certain keywords must appear in the definition. Number 1, we must say it's a sharing of electrons. Number 2, it's between two atoms to form a molecule. So that is what the 2 marks is for. So okay, a covalent bond is the sharing of electrons between two atoms to form a molecule. Now for the Lewis structure, we need to know how much valence electrons we have. So we have carbon, 3 hydrogens, and we have chlorine. So carbon here is the central atom. Carbon is in group 4 in Roman numerals, so it has 4 valence electrons. Alright, hydrogen is in group 1, so it has 1 valence electron. And chlorine is in group 17 or group 7 in Roman numerals, so it has 7 valence electrons. So if I take carbon, we'll make 1, 2, 3, 4 around carbon. Chlorine has 2, 4, 6, and the 7th one combines with 1 carbon there. So that's 7 from chlorine plus the 1 from carbon, form an octet there. Then there, hydrogen combines there, the 1 valence electron from hydrogen with the 1 from carbon. There again, 1 from hydrogen, 1 from carbon, and 1 from hydrogen, 1 from carbon. Alright, so my valence electrons are correct. 1 mark for the carbon, the central atom. The second mark for not leaving out any valence electrons, and your valence electrons are adding up correctly. For CO2, again carbon has 4 valence electrons, so there's 1, 2, 3, 4. Oxygen, group 6 in Roman numerals, so therefore has 6 valence electrons. So there 2, 4, 6 for oxygen, 2, 4, 6. Oxygen, when it combines with carbon, will form a double bond because oxygen wants 2 electrons to get to 8, and carbon and therefore gives 2. So double bond, double bond. So there 1 mark for correct amount of valence electrons. Second mark for grouping properly in a linear shape. Right? 2.3. How many lone pair electrons are in the central atom of CO2 molecule? So we look there, those two are joined, it's paired. Those there is paired, there's nothing alone that's not paired with anything, so therefore the lone pairs on CO2 is 0. There's none. Alright? All the valence electrons have bonded. Alright, so I hope that makes sense. Let's go to the next question. Identify one of the substances in reaction 2 that can form a dative covalent bond when reacting with acid. So just to refresh, dative covalent bond is where hydrogen loses an electron and therefore is able to slip over an empty orbital. So in this case here, H2O can still take a third hydrogen and become H3O plus when it reacts with the acid. So therefore, my one dative covalent bond, the hydronium ion, and the other one we look at is ammonium ion, right? So H2O. Write down the shape of the H2O molecule. So H2O, oxygen central atom, 6 valence electrons, 2, 4, 5, 6. One from hydrogen and one from hydrogen, and as you can see, that is angular or bent. 2.5.2 CO2 molecule. CO2 is linear. As you can see, we did in the previous, it combines in one straight line, therefore it's considered to be linear. So we need to know our shapes because that's an exam question. Now 2.6, this question we test over and over. So I'm going to go through another 4 papers to show you the similarity in what we test. I hope you pick up how we test this question over and over. Alright, so although the molecule of CH4 and CH3Cl have the same shape, CH4 is non-polar while CH3Cl is polar. Give a reason for the difference in molecular polarity. So there, CH3, I have carbon with 3 hydrogens. Right, and if we had to subtract the electronegativity, their values would be the same, but chlorine has a different electronegativity, which then means it will make CH3 asymmetrical. Where with CH4, all 4 sides of it is the same, therefore it is symmetrical. So because this one is symmetrical, it will be non-polar, and because that one is asymmetrical, it is polar. Right? Meaning one side there, chlorine and hydrogen don't have the same electronegativity. Hope it makes sense. Alright, see you in the next question, where I'll be looking at question 2, November 2018, and then we're going to do 2019, 2020 in that order, just to show you what we test, what is the same, and what you need to know. Okay, God bless. Bye.